Alrighty, so we're gonna do this second page and do kind of one from each category on the second page in your review packet. So you might want to get the review packet out. Oh. Yes, I did participate in Senior Citizens Day. This hoodie is older than you. This is legitimately from my high school days. Which is why it's so ragged. These sleeves were double long. Oh, yeah. Let me get you that. That's why I put it over here. Oop. Ready? Okay. So we're going to look at number 10 because it kind of covers a lot of the things on the rest of this page. Or at least on the rest of the exponential stuff that I've looked at so far. So, first thing we're asked to do is we're asked to name what kind of function this is. What kind of shape does that? I was bad at that. There we go. Let's try that again. This is an exponential function. I don't know why my line is really small. We can tell that from the equation because there's an x in the exponent. Exponent, exponential. If there's an x in your exponent, it's an exponential. Then we're asked to find the equation of the asymptote. Remember, asymptotes are those walls that our graph can't cross through. To me, it looks like I've got an asymptote right around this space right here. Which means this number on my iPad, I can see it up there. You really kind of can't. On your paper, I think you can see that that has a -1 in there. So our equation is that this is the y-axis, so y is stuck at -1. So the equation of the asymptote is y equals -1. When it comes to stating the transformations, it might help to have our transformation form written out. So y equals a b x minus h plus k. So what are the transformations that we have on this one? Looking at that equation. Let's start with what's A? Which one's A? 3. A3. 2 is our base. So 2 does not have transformation. 2 is just where it is. So our A is 3. What does that do as a transformation, an A of 3? What does an A that's bigger of 1 cause? Stretch. Yes. Yes. Oh, good. All right. What's our H value? -1. Which means what happens? What does H tell us? That is 100% not the graph that's pictured, but that's okay. H equals -1, which tells us it goes left 1. What does K tell us? Down 2. So K equals -2, so this one went down 2. Yeah, 100%, that's not the graph picture, but that's okay. All right, so we're gonna look at the picture and we are gonna identify our domain and range. So our domain, what X values work? Well, all of them. I have an arrow that goes this way and I have an arrow that's going up and out that way. So our domain is all real numbers. Or you can say it goes from -infinity to +infinity. What's our range on the picture? Is it going to be all real numbers again? What's the smallest my y can be? -1. So my y has to be bigger than -1. Or -1 to infinity. However we want to notate this for our domain and range. Number 11 on this page is very, very similar. Identifying these pieces. You're going to find your A, H, and K. You're going to state what transformations it is. It just doesn't give you the picture. For this second one, let's see which one we want to do. Let's do A for number 12 here. So first things first, we're asked to rewrite this into log form. What they mean when we say log form, that's when we had our BP equals A. Our base power gives us an argument. In log form is log base B of A equals P. That's probably going to be one of those things that it helps to know. BPA log BAP. I said that a gazillion times when we did this chapter. So we are asked to put this into log form. So we have our base, our power, and our argument. So when we put this in log form, this becomes log base 2 base 2 of our argument 1/32 equals X.
What's the formula for this again?
It's not really a formula, it's just kind of the form, but that's these guys over here, BPA log BAP. Base power argument becomes log base B of the argument equals your power. From here, in order to be able to solve this way, if we don't notice that we probably could solve it from here, we're going to need to know our change of base so that we can type it in the calculator, which is where we have log of our argument, common log, divided by the log, common log, of our base. That's what the change of base formula was way back in the day. Argument over base. And from there, I can type the dang thing in the calculator. So we're going to have a fraction. And on the top, I'm going to do the log of 1/32 And in the denominator, I'm going to do the common log of 2. And what we get is -5 as our answer. Which, if you look at the exponential form, you might be able to do from there. Recognizing that 32 is x to the 5th, or is 2 to the 5th. But switching it into log form, and then you can use change of base to type this guy in the calculator. B, you can kind of straight up type in the calculator. You still need to write it in log form because it specifically says to rewrite it in log form. But you can type this guy in the calculator in exponential form to get the answer. For the second one here, we're going to use the same kind of process here. We're going to take log base 3 of the argument equals the power. So rewriting this, we get 3 to the 7th equals x. Oh, I switched my colors around all kinds of different, but that's okay. Still works. So switching the log to the exponential form, we can type the dang thing in the calculator again. 3 to the 7th, 2,187. If it doesn't have a base here like A, what's the base on this one? 10. When it's ln, like C, what's the base on this one? E. This is the same thing as log base E of x equals 3. Okay, so just be careful with those, but otherwise, that's how we do those. Questions on the first page of that? We're going to do a little bit of our expanding condensing on the next side, or where we're solving. So I'll do B. I'm just feeling like we should do an E one. So when we're asked to solve, the thing I need to do is get this chunk by itself first. I need him by himself so that we can deal with log stuff. I don't want to deal with log stuff when there's stuff around it. So what am I going to do first to get that purple chunk isolated? What do I do first? Not the square root of. I want purple isolated, so get everything outside the purple to go away. So we need to isolate our exponential. Y'all, your test is in a week. What are we going to do first? What if this was 2, something, let's do x minus 7. How would we get the x by itself? 2 something minus 7. I want purple isolated by itself. So what do we do? Add 7. And be like, we are either not paying attention or we are 100% tuned out. It's going to make this final really hard, y'all. So what we have is 2e to the minus 4x equals 9 plus 7 is 16. I still want that purple chunk isolated, so what do we get rid of? What do we do with the 2? Divide it, because this is currently multiplied against it. So divide both sides by 2. So now I have e to the minus 4x equals 8. And that's gross. We have an x in the exponent. To get our x out of the exponent, we use our switching into log stuff. So we're going to do our base power argument and switch it around. So we're going to have log base e of 8 equals negative 4x. Log base e, we just talked about that. That's ln of 8 equals negative 4x. How do I get x by itself?
Divide negative 4.
Yes, there we go. Divide negative 4 on both sides. So we're going to have two ways of writing this solution. X is ln of 8, natural log of 8 over negative 4. Or to get our decimal estimate, we type that sucker in the calculator. Or we're going to have a fraction that is the natural log, ln, it's the third, it's just below the log button, of 8 over negative 4. Whoa, not what I meant. Swap it back, thank you. Negative 0.5199. So we can leave it in our logarithmic form, which is what I'd call this. Or we can get it as a decimal. Read the instructions on tests and stuff, and it'll tell you which one we expect. There might be times when you're expected to do both. Questions on that one? All right, we've got a condense, an expand, and a solve. So condensing and expanding are the same steps, which you may want to have. That's our powers become multipliers. Subtraction. Let's try that again. Becomes division. And addition becomes multiplication. You can also, instead of the word multipliers, put coefficients. And so when we condense, we go this way. And when we expand, we go that way. It's also going to be right to left. So when we are condensing, oh, sorry, I have the top one 100% backwards there, and it is in the wrong order. I'm going to rewrite this one. So it's just that our coefficients become powers. Or multipliers. I knew something looked wrong. but I couldn't tell what it was. I just had it flip-flopped. It's still powers and coefficients or multipliers. Coefficients or multipliers. Because when we are condensing, the place we start is these guys out front. Become exponents on our arguments. So this is going to become log base 3 of x squared. Let's get that number clear. And log base 3 of y cubed. And log base 3 of z to the 4th. So each of those multipliers, each of those coefficients becomes a power. So then we're going to do our subtraction becomes division. So what we're going to do is we're going to take these guys, and our two arguments are going to divide. So this first guy's not involved in the process right now, so he's just going to drop on down. Log base 3 of x squared plus. And the whole point of this is to make us write log fewer times. So we're just going to have 1 log base 3. And I'm going to take my y cubed, that was then subtracted, by z to the 4th. So subtraction becomes division. That's what we mean by subtraction becomes division. And our last one, addition becomes multiplication. So again, the whole goal is to write log fewer times. We're going to wind up with just one log here. Log base 3. I'm going to multiply this times this, which is just going to put that guy on top. X squared y cubed over z to the 4th. In the next one, it's very similar vibes. We are just going to expand. So I'll do the ln one so that you guys get practice with the base. So I'll do B because it also has all the things. So when we're looking at our list of instructions, we're going to be careful here. We're going to wind up writing more logs. The whole point is to expand this out. Since I have some kind of combined things on there, I'm actually going to do the subtraction first. So what we're going to have is my natural log of the top, my numerator, 3x squared, minus the natural log of my denominator, y cubed. Division became subtraction. Then I'm going to do my multiplication. Since we had a grouping up here, it was order of operations situation. So then I'm going to take this guy, and we're going to separate out the pieces that are being multiplied. So we're going to have the natural log of 3 plus the natural log of x squared minus the natural log of y cubed. And then our last piece is to grab those powers and bring them down as coefficients. We're going to have our natural log of 3 plus 2 natural log of x minus 3 natural log of y. And that is as far out as I can get that. I can't do anything to make it bigger. The whole point of expanding is trying to make it as big as possible. Any questions on the expanding or the condensing? Okay, our last one down here, 17, we'll do module 9 tomorrow. I feel like we've done enough things. We'll just do 7 and 8 today. So we'll finish out this last question in module 9, or module 8. And then tomorrow we'll look at rationals. There's a couple of ways to do this. You could absolutely do this with logs. Totally fine, absolutely a thing. The easier way is to go, is there a way to get those bases the same so I can just like cut out the middleman and just deal with the exponents? So my smaller base here is 5. So is there, I can write 125 as an exponential form of 5? How? I will never change the smaller one. The smaller one's gonna stay. Okay. I can only make them smaller. So it's not that I might never change the smaller one, but I will never make the smaller one bigger. 5 to the what is 125? What? Yeah. I can rewrite 125 as 5 to the third to the x minus 9. That's the same thing. It means the same thing. Which means I can write this as 5 to the 2x equals 5 to the 3 times x minus 9. Which right now does not look better until we remember that if the bases are the same, they can just disappear and we're left with 2x equals 3x minus 9. If your bases are the same, just look at your exponents. I'm going to do this so I can write up at the top again. So what can I do down here to start to solve this? Distribute. We're going to have our 2x equals 3x minus 27. Then what are we going to do? Subtract the 3x. Let's get those x's together. How many x's are we left with on the left side? Negative 1x equals negative 27. So what does x equal? Positive 27. So when you have these exponentials, even if they say anything about logs, you can absolutely solve these using our exponential stuff. You can do it with logs. It's kind of gross, but it's doable. Okay? There are about 10 more minutes until announcements. I'm going to say let's do rationals tomorrow because that's enough of logs and junk. So we'll do Module 9 tomorrow. We'll do a quick talk through Module 10, which we should hopefully remember on Friday. Monday will be your last day to work on stuff and ask questions in here. Monday, you're also turning in your review. So, or you're turning in your reference sheet. You can turn in the review too. I will always give you points for doing reviews, so it's easy peasy points, especially when we're walking through half of it together. Turn things in, take easy points. Okay? Your final in here is a week from today. A week from right now, you'll be in the thick of it. You need your Chromebooks for the final. If you do not know where your Chromebook is, find it and find your charger. Okay, I don't have any extra chargers, So bring it. You can plug it in. I've got enough extension cords that you could all plug in. But you're gonna need your Chromebook because the multiple choice is on Canvas and you can't do it on your phone. It's drag and drops. Those don't work well on your phone. Okay? You gotta have your Chromebook. You have one. You were issued one. If it's broken, take it to the library. They will replace it. Take it in the case and they'll fix it. Okay? So, do the thing, ask the questions. Huzzah.